All right, so double check, make sure you have the right roadmap in front of you. We should be looking at Module 3, Lesson 16 today. And I guess let's go and start with the aim. Sorry, I'm on the wrong page here. Let's start with the aim. And our aim today is going to be, Kipster's will be able to describe reflections on the coordinate plane using opposites. Reflections on the coordinate plane using opposites. So if you think about what a reflection is, I mean, when you look in the mirror, it's the same thing as what you see. It's just flipped over. So we're going to look at these on the coordinate plane. So same thing, we're looking at our points from yesterday, but now we're going to reflect them over axes. Let's take a look. So this first thing asks that we take these points that we're given, and it asks that we take these points and that we put them on the axis, or on the coordinate plane, and start to describe some of their similarities and some of their differences. So let's take this first coordinate of 3, 4, and negative 3, 4. So I'm going to start with the left column here, the furthest left column. So if you look on my page, this is the column we'll be filling in right here. So it says 3, 4, and negative 3, 4. Let me adjust my camera here. I'm running out of space. Okay, so 3, 4, well that would be right 3, up 4, 1, 2, 3, 4. But then it also says negative 3, 4. So 1, 2, 3, still up 4. So there are my 2 points for this first left column. Now the first thing it asks me to do with these points is, how are the coordinates similar? So let's look at these coordinates. How are 3, 4 and negative 3, 4 similar? Well, which one do they have the same? They have the same y. They have the same y coordinate. And of course, how are they different? Well, their x coordinates, the x coordinates, which are 3 and negative 3, well, what do we call numbers like 3 and negative 3? We call those opposites. So we say the x coordinates are opposites. And so let's look at now their location. So the next thing asks us, how are they similar in location? Well, let's look at these 2 points. As you can see, they look like they are the same height. The same height, or the same distance away from the x-axis. So let's write that down. Similar in location, they have the same y-axis, and that kind of means they have the same height. Well, let's think about how they're different then. Well, they're the same height, but when I look at them, I can see, oh, one's on the right side and one's on the left side. So I can say they are on, let's see, opposite sides of the y-axis. So if we think about the relationship between the coordinates and the location on the plane, well, take a look at this. We know with a reflection, or you can think of it as like a line of symmetry, if I have this x-axis right down the middle, try to do this with my ruler as best I can. If I have this x-axis right down the middle, I can clearly see that this point is 1, 2, 3 away, 1, 2, 3 away from the y-axis, and so is this one, 1, 2, 3 away. So what we've done is we've essentially taken this y-axis right here, and we've reflected our point over the y-axis. We can see that because they have the same absolute value for their x, but they're both the same distance away from 0 on the x-axis. So again, down here in this bottom one, what's the relationship between the coordinates and the location of the plane? Well, they are, it is reflected over the y-axis. And again, why is it the y-axis that's reflected over? Well, let's look at our picture again. We can see this is my y-axis always. The vertical is always the y. This is my x. It didn't flip over the x-axis. It stayed on it. What it did was it flipped over the x-axis. What I urge you to do is try to complete this second column on your own. So plot these points and then try to describe what's going on in here. And then check it, come back and check it after you've done that. And then try the third column and see if you can do that one as well. So hopefully you're back from your work as you try to do that on your own. Let's look at these together now. So this one is 3, 4, so same point as before, right here, same point. But then this new number is 3, negative 4. So I'm still staying to the right 3, but now I'm going down 4 because it's negative. So here I have 3, 4. Okay, 3, negative 4, 1, 2, 3, 4. Here's my new point. So this is for my second column. So now it looks like, I probably don't have a reflection over the y-axis. It looks like I might have a reflection here. But let's still describe. So the similarities of the coordinates, well, how are they similar? They have, this time they have the same x-coordinate. So that first coordinate is the same. We can see the 3's are the same. How are they different? The y-coordinates are opposites. The y-coordinates are opposites. And so how are they similar in location? They obviously have the same x-axis. So they are on a vertical line, We can see that up here, because if I put a line between them, I would see, okay, they are on the same vertical line. How are they different in location, though? Well, we can see one is above, one is below the x-axis. So here we could say they are on opposite sides of the x-axis. So what do I call these? This is a reflection over the x-axis this time. Reflection over the x-axis this time. All right, so let's just go ahead and take a look at this next one really quick. So this time it's 3, 4, so same starting point, but now it's negative 3, negative 4. So this, well, I guess let's go back to the last one. On the last column you just did, we can see it's a reflection over the x-axis. 1, 2, 3, 4 to get there, 1, 2, 3, 4. So it's a reflection over the x. Now, check this out. Our last point is actually right over here. So we went from this point somehow down here. Well, how did we do that? Well, technically what you could do is you could reflect here and then reflect here. So we call this a double reflection. So in that third column, what happened there? This is a double reflection. Kind of weird. Don't see those too often. Double reflection. So basically, to get a preview of your long-term memory chunks, if you have two coordinate pairs that have an identical number and an opposite number, they are said to be, so let's take an example. Let's say I have 5, 2, and 5, negative 2. What do we call these 2 points? We call these 2 points reflections. Reflections. So another example would be if I had negative 3, 7, a reflection could be 7, positive 3. So this is a set of reflected points. This is a set of reflected points. But let's go ahead and look at these on the coordinate plane to continue to practice what these things actually look like. So go ahead and move on to the next page. And in this one it says, write the coordinates of the points that are related to the given point. Oh, that's a lot of words. It basically says take this point right here in this column, label it, and then do all of these directions and write the new point. So let's try this first one. So this first one says given point S5, 3. So here's S, and it clearly went 1, 2, 3, 4, 5, up 1, 2, 3. So there's S5, 3. So it says reflected across the x-axis. So here's my x-axis. If I reflect over it, I end up at M. And M obviously still has 5, but now instead of positive 3, it's down 3. So what if we took that same point and we reflected it across the y-axis? This point, but this time reflected across the y-axis. Well, if we do that, my new point, I'm still 3 up. So this point's still 3 up, but what's different this time? Instead of 5 over to the right, it's 5 to the left. So I say negative 5, negative 5. So those are my 2 points so far. Now this last one says the given point is reflected first across the x and then across the y. So it says take my same S starting point, go across the x first, and then reflect to the y. We end up at A. We end up at point A. Now on the last one it says go across the y-axis, then the x-axis. Guess where we end up again? It says go across the y, go across the x again. So when we do one of those double reflections, we always end up down here, as long as this is our starting point. So what you should do now is you should take this point right here. We don't necessarily need to do all of these, but just go ahead and take this one right here. So -2, 4, 1, 2, up 1, 2, 3, 4. Let's just label that point x. So I'm going to label that point x. And you're going to do the same series of directions here for point x. If you're not done with this in about 2 minutes, why don't you go ahead and press play again on the video so you can make sure that you get the answers to this one. So again, try this one on your own and then but only for about 2 minutes, and when the 2 minutes are up, go ahead and check the answers with the video. Okay, so hopefully you had a chance to take this point and reflect it a couple times. Let's look at it together. So the given point is reflected across the, first one, x-axis. All right, so let's take this point, let's reflect it across the x. Well, here's my x-axis, the flat one. It says reflected across the x. So that means I need to go, I'm 1, 2, 3, 4 away. So if I reflect it across, I should end up 1, 2, 3, 4 down. So here's my first reflection across the x-axis. So that looks like it's the point -2, comma, well now I'm not 4 above, I'm 4 below, so it's -4. What about the next one, the given point reflected across the y-axis? Well, here I am, here's my y-axis. This time I'm not reflecting like this, it says over the y, okay, so I'm going to go over the y-axis here. I'm 2 away, so I go 2 more on the other side. There's my reflection across the y-axis. Now, I'm not 2 to the left, I am 2 to the right, so it's positive. But I am still 4 high, so I say 2, 4. Let's go ahead and try these other two. Remember, the other two are double reflections. So it wants us to go x, then y, and then for this one, y, then x. So let's watch what happens here. First it says go x, then y. So here I am. Reflect over the x, reflect over the y. Here's my new point. What's that point? Well, it's 2 to the right and 4 down. So it would mean 2 to the right, that's positive. 4 down, that's negative. And for our last box right here, it says to do the y-axis, then the x. Guess what? We're going to end up in the same location. So it says do the y first, followed by the x. So we still end up down here at 2, -4. If you have any time left, if you worked through this video really, really quickly, I would urge you to try these 2 columns right here. And then I'll put the answers up here in just a second. But if you don't have time to get these 2 columns, that's okay. We'll continue to practice these a little bit in small groups. So here, if you did go through and complete it, here would the answers be. This first one, 3, -2, it's over the x-axis. Okay, well here's 3, -2. 1, 2, 3, down 2. Over the x-axis would mean over the x-axis, so I'm still at 3, but this time it's 2 positive. Next, it said over the y-axis, so this time I'm at -3, -2. And then finally, for these last 2, you're going to end up with -3, +2, and -3, +2. So maybe you start to see a pattern here. When you reflect over the x-axis, that y-coordinate changes. So here, this one would be -1, 5. But if you reflect over the y-axis, the other one changes. So instead of -5 stays the same, but the -1 changes. And then of course, if you do a double reflection, both points change. So your double reflected points would be 1, 5 and 1, 5.